Welcome to episode 10, the final part of the GPIO series, in which we look at advanced plumbing and how you can put together your own GPIOs using the same building blocks that the built-in ones do. First, some important items. I'd like you to subscribe to the channel. I need all the help I can get. Click on the like button because obviously you're going to like this video. Then click on the bell notification icon to get notified of all updates. And finally, support me on Patreon if you can, please. There's a link in the description below. All donations gratefully received. Now, at the end of the last video, I told you a bit of a fib. I said, oh, that was the end of the GPIOs. I forgot that I had this other example here showing how the GPIO works in detail and how you can make your own using some of these extra node pink nodes or filters to do some quite clever things. As usual with all of these sketches, the global event handler's down there out the way. We've got the on GPIO, which is the same as ever, just shows us that. Let's ignore all that and let's concentrate on this piece of code from here to here. Because from everything you've seen so far, you have a named GPIO object like an H4P retriggering or a latching or a rotary encoder, and they have predefined behaviors which we have seen briefly is based on this concept of node pink, where it passes messages from one to the other. And what you haven't seen so far is the under the hood part of it, where what a pipeline looks like. Well, let's just go through this code one line at a time and you'll see how it all hangs together. So this is an H4 GPIO object. It's a class and it takes a pin number. We're going to use the analog pin just because it makes the results easier to understand and explain, but it can be any pin. We have a pin mode, input pull up, and we have a sense whether it's active high or active low. Now that's actually a bad value to choose in there. I'll change that in a second. Because that really only applies when we're talking about the built-in LED, and actually it's completely ignored when we're looking at the analog input, so it doesn't really matter what you put there if you're using the analog pin. But moving on, what we have here as the final parameter is a block of data, and that block of data is a list of node pink nodes. Some of them already exist, and I'll explain why in a minute. But the ones that you're going to want to use, you have to create a new instance of them because they don't already exist. And sometimes you might want to pass parameters to the nodes. So basically what happens is this, is that once you have a sorry, it's getting late here. Once you have an H4P GPIO, and some GPIO activity gets detected, then this is the pipeline. And you can see at the end that we've got a node pink node that publishes the value. That's the thing that causes the GPIO event to occur. That's the thing that gets replaced when we use those fancy update int and update globals. And everything in between gets passed from one to the next, to the next, to the next, to the next. Now I've got some stuff in there commented out because we can look at those later. But the most important thing is that when you create, for example, a retriggering GPIO, it's just a GPIO with the particular retriggering nodes in its list. A debounced is just a GPIO with particular triggering things in its lists. So what we can do ourselves is we can create a GPIO with any kind of triggering or management in its list that we choose, and that's what we do here. Before we look in detail at how that actually works, we need to talk about this in the setup function, because it's to do with this first node in the pipeline. That node only passes through inputs which are generated by a timer. That is how all of the polled functions work. They don't actually look at the state of the GPIO pin. They look at the input from a timer, and when that timer expires, they read the GPIO pin and then they pump that into the pipeline as if it had come directly from the GPIO. So anything that's going to poll its input has to have an NP pass timer at the start of it. Otherwise, all of the real hardware changes will pass through whenever they change, which could be thousands of times a second, and we don't want that. So the pass timer makes this thing that we're building behave like a polled function. And what actually then runs the clock on that is this function here, periodic read on A0 once per second. And that's a public static method of the pin machine object, so you don't need a pin machine specifically. But that basically just sets a timer which reads A0 once a second and pumps the result into this pipeline, because that's listening on A0. And that pipeline says, did this event come from a timer? If not, end of pipeline. If it does, it then passes it to a rolling average node. Now, we saw in the last video what that does. It produces that rolling average. What a surprise. Now, the pass timer and the publish value are so common that to save time and make things more efficient, H4 Plugins has its own little private copy already created, so you don't have to create it every time. However, it cannot possibly predict what you're going to want to use, so you've got to create your own. So, rolling average. We then take that rolling average and we pass it to a thing called a low pass. Now, if you know anything about electronics and signal, digital signal processing, these are just like the kind of hardware filters you put in. A low pass filter basically only passes through low values. So you put in your threshold value there, that will only pass through values below 230. We'll look at some variations of it in a minute, but we then pass that to a node called value diff, and that value there is the little hysteresis value, and that says only pass value through if it's different from the previous by more than this hysteresis value. So just a quick recap of what we do there. Every 1 second we read a value from the A0 analog input. We calculate its rolling average based on the previous inputs that we've received up until this point. We then say if it's below 230 we'll pass it on. If it isn't, we just exit and end of it and nobody knows any different. Then we say if that value below 230 is different from the previous value by at least a factor of 5 points, then publish the value. And that then causes a GPIO event to occur. That's when this code jumps in and we print the value. So let's go to the live lab. As you can see already, it's plugged into the positive rail It has been for a long time. That's why it's not producing anything, because the value is different. Also, the value, if there was one, would be 1023, which is higher than the low pass figure that we've set. So it's not going to get through anyway. That's why you can't see anything happening. But as soon as I change this to read a 0, that is below 230, it does differ from the previous by 5, so it'll start talking to us. Why do these things always happen to me? Is it because they are live, or is it that I have loaded something different into there? Let me just... Has it come loose? Yeah, loose wire. Loose wire is all that's happened there. Apologies for that. As you can see now, all of those figures are below 230. They all differ from the previous one by at least 5, so they're getting passed through. And where you see a pause of more than a second, it's because the value hadn't changed. Right. Now that we know that, I have to be very careful with these wires, but now that we know that, let's stick it back up to 1023. So the rolling average is gradually increasing, as we'd expect, but once it gets within our threshold figure of 230, it stops passing them through because of the low pass filter. So that is how to build your own pipeline to make some quite sophisticated signal processing values on the analog. Let's stick that back down to 0 again, just for fun. Now that we know it's working. Have I lost it again? Have I got the loose wire problem again? There's some kind of issue here that I don't understand happening. Oh yeah, I do understand it. All the values are still above 230 because it's been at 1023 for so long. I guess. Okay, now I'm not going to spend time recompiling the program and trying it out with each of these other ones in here, but I have put them in there so that you know what's on offer. So a high pass filter is the opposite of a low pass filter. Only values above whatever you put in there will get passed through. A band pass filter is like a combination of a low pass and a high pass. It just passes a big lump in the middle defined by the lower bound and the upper bound. So here it will pass only things between 150 and 1000. There's then what's called a notch filter, which is the inverse of a band pass. It passes everything except what falls into that gap. So you get like a notch in the output if you were graphing it. Oh, there we go, look. This sometimes even my own code surprises me. So it was working fine. It's just taken this long for the rolling average to have come down below 230. And then it just bursts back into life on its own, which is, I was disappointed 2 minutes ago. I'm pleased now. Anyway, just to recap then, H4 GPIO is the fundamental unit of object that manages a GPIO in H4 plugins. Predefined ones have a well-known, they have a well-known list of nodes in their pipeline, which generally end in a published value. We know ways of plumbing on a different one at the end in certain cases. Where they start with a pass timer, it makes them into a polling function rather than a reactive real time to the actual GPIO input. And in between, we've got a vast variety of either predefined ones that you know about already, or ones that we can put together ourselves using these filter kind of functions. And that, dear friends, Thank you for sticking with me. Truly is the end of the GPIOs. There's plenty to go on there. There's plenty to keep you busy until I get your next video ready. And I think we're going to start looking next at getting connected to Wi-Fi and looking at the web user interface and all things networky, because that's when the real power of H4 plugins starts to become apparent. So as usual, thanks again, and 30 seconds of silence till the end credits come up. See you next time.